Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond Cloud Security series. Our topic today is Protect Your Tenancy from Ransomware-Style Data Integrity Threats. You will learn about how to leverage OCI capabilities to reduce your attack profile and build cyber resilience into your tenancy. My name is Bhakti Moharkar. I'm Cloud Engineer with Customer Enablement Team. Today, we have with us Chad Russell, Senior Manager Field CISO Team, and Kurt Hagerman, Field CISO here at Oracle. With that, I'll hand it over to Kurt.
Thanks, Bhakti, and welcome everyone to the webinar. We hope you find it interesting. So just a quick agenda. We're going to talk a little bit to set the stage about cyber risks and trends over time, what we call our cyber trifecta, talk about cyber security, which is an important foundation for any sort of protection program, and then pivot over to the cyber resilience slide. So the modern risk landscape. So if you look at the evolution of ransomware, it started probably back in the early 2010s with things like CryptoLocker. It was basically individuals, I call them bored teenagers, in their parents' house, who were figuring out ways to go and extort people, individuals. So it's basically one-on-one, single device kind of things. People were figuring out that they could go lock up somebody's computer and get them to pay them some money to get it unlocked. A few years later, they evolved to more rapid destructive attacks like WannaCry and NotPetya, where it was mass distributed, automated, sort of commodity-based ransomware, but they were more destructive. They were using encryption as a way to destroy data, and they hadn't really figured out exactly, how to move into, a more financially motivated model. And then around 2019, the criminal organizations and nation states really got involved in this space and really expanded the scope of extortion, right? So they were targeting now individuals or mostly corporations. They were using more human operated ransomware. So it wasn't just automated tools. They were, there was more thought behind it and there was more process behind it from people. And when they would get into organizations' networks, they were starting to do what we saw as sort of double extortion tactics. They were locking up the data and saying, hey, you need to pay us in Bitcoin normally to get the key to unlock the data. But they were also stealing the data first. And then they would, if you paid, then they might come back later and say, hey, well, we've also stole a copy of your data. And if you want us to stop from publishing this out on the dark web or other places, you need to pay us again. And as part of this whole evolution, they started looking at how they doing data integrity attacks, like injecting malware into data that was sitting there. So it's not just always about encrypting it, but it was injecting malware that could do damage to the data, as well as they started attacking backup infrastructure because they realized that if people had good backups, then they weren't going to pay them once they locked it up. So they started including a more wider scope when they got in the organization. They'd get a hold of the production environment and they'd immediately pivot to try to find where are the backups and lock those up as well. So how did the market respond, or how did the environment respond to these kinds of threats? So, started out early with the prevention, sort of keep them out, right? It's the old castle and moat sort of security doctrine, because everybody's, back in those days, there wasn't widespread use of the cloud. So there was a lot of on-prem things. So everybody thought, well, it's my environment. I'm going to lock it down from the outside. I'm going to keep people out. And then they realized a few years later that wasn't necessarily, doing the right job, right? They were trying to keep people out, but as often as you do that, there's still going to be ways for people to get in. So we moved into the detection era. And this is where we started seeing threat hunting behind the firewall, um, people enumerating IOCs, indications of compromise. Um, and so we're starting to see, okay, hey, we see these IOCs out there. Let's go back and look at our log data and see, have we been hit by this? But again, that was behind, that was always after the fact, right? So you move into now the 2020s, and we've moved into sort of the containment era. So really the thought process there is assume breach. Assume that someone's inside your organization. So how are you going to contain that and limit the damage, right? So we're looking at things, how people are doing blast radius containment. So better segmentation, and then also, if we know we're going to get hit, how do we prepare from a data resilience perspective to deal with those kinds of attacks? So when you follow the NIST framework, we've now moved to more of a looking at the respond and recover piece. So when you look at protect and detect, like how do you keep people out? But when you're thinking about it, you still need to do the protect and detect. You have to nail the basics of cybersecurity, right? It's not exciting work. It's kind of the basics, but you need, most of these attacks are leveraging poor identity and patching controls, right? So identities are getting stolen, and systems are being compromised because they're not being kept up with the patching. So, what do you got to do? You have to make sure you patch host systems. You have to have strong identity management systems where you're doing multi-factor authentication against not just the more critical data, but into basically all systems within your organizations. That's a fairly frictionless way to help minimize the ability for compromise of credentials. Also controlling network traffic using more hub and spoke technologies and next gen firewalls. This gets into the containment era where you're segmenting your environment and having strong network controls. So it makes it more difficult for the threat actors to move laterally through your environment. And then, making sure that you're doing, can you go back, please? Making sure you're doing standard backup and recovery. And then also moving your focus not just to cybersecurity, but adding cyber resiliency to that as well. So when we start talking about cyber resilience, everybody's familiar with disaster recovery, right? And cyber resiliency and disaster recovery are not the same, right? DR, traditional disaster recovery, was aimed at failures, hardware failures, network failures, data center issues. So things where stuff would break. And so, the common practice there was to have another set of infrastructure in another location, geographically enough separated so you didn't have regional events taking them out. But there was no real thought towards what am I doing other than just replicating my data between site A and site B. And so with these new ransomware attacks and with data integrity being part of that attack flow, it's like with just traditional DR, if you've got someone in your production environment and you're just replicating bad data to your DR environment. And very few companies actually did real testing of DR. They would do some failover occasionally, like once a year. But there was not a lot of attention being paid to the data that was being backed up in those other locations in terms of, is that good data? Is it valid? Can I use it? So when you're thinking about cyber resiliency, there's some things, you have to have enhanced data integrity checking along the way to make sure that you're checking and doing everything you can to validate that the data you're backing up is actually good data and hasn't been manipulated. You have to have some enhanced separation of duties, right, into the process. In most environments, there's a lot of companies still that give too wide-ranging access to a small group of people. So instead of saying it's more role, you have to start looking at better role-based access, don't give broad privileges to your system administrators. And then, we're talking about between your production and backup environments, you need to have effective administrative, logical, and physical separation, right? So when we talk about administrative, we're saying don't have the same sort of admin construct over your backup site as you do over your production site. From a logical perspective, it's have different identities. The same identities should not be able to be leveraged, used to access your backup environment as are used to access your production environment. Once again, separating that out makes it more difficult for threat actors to move laterally, right? If they compromise a production credential, but that production credential can't be used in the backup environment, then that's a way to do that, as well as physical separation from separate networks and much stronger and more restrictive network controls. And then when you're looking at structured data from like a database perspective, because of the rate of transactions and the amount of change in data and just the amount of business that's being done, you can no longer rely on a daily database backup, right? So you have to have single transaction level backup and recovery. So you have to be able to recover your data back to a smaller and more discrete point in time, or you face larger issues as an organization. And then when you're talking about being able to recover this data, it has to be you have to have the ability to recover that data quickly, right? So this idea, this data must be available to hydration mechanisms, what we call them, of great speed. So when you're talking about like a recovery environment, that has to be automated. You have to be able to have automation that can spin that environment up very quickly, and then be able to have that data recovered into that environment. So the cyber trifecta, I think this is this is just kind of a recap of what we've been talking about. So we've talked about cyber security and disaster recovery. We need a new approach, right? Sort of this what we call our OCI cyber well architected, which combines the elements of cybersecurity, which is the protect and detect stuff, which in OCI is powered by the CIS landing zone, right? So we have published a landing zone out there that assists you in deploying your tenancy in a very secure fashion, right? And meeting the CIS Foundation benchmarks as well as OCI best practices. DR is still very important. You still have to have that ability. No data center provider is perfect. There's going to be hardware failures. So, DR using Oracle's maximum availability architecture can help you stand up alternate environments to keep your business running. But you now need to add in this whole cyber resilience where you have to start thinking about that it's not just DR. How am I going to make sure that my environment, that I'm ready for an attack like this and ready to be able to respond and recover quickly so that my business isn't shut down for weeks or months. I need to be able to recover within hours or days. So digging in a little deeper in the cybersecurity, this is the secure landing zone. This is really an example of how the landing zone sets up this logical separation, role-based access, and really creates an environment that is secure by default when you start. So, I mean, this is a kind of bit of an eye chart slide, but when you start looking at it, you can see I have separate compartments for my different functions, and I have different administrative groups that are responsible for those. So I'm not spreading, I'm not providing too broad a privilege across my environment. You have a network where you have very strong isolation and segmentation of the different workloads and the different sections of the workloads, so you have better control over how that environment is set up, which again, making it more difficult for an attacker to come in and move laterally, either logically or through the network, to compromise large swaths of your environment. So, let's kind of set the stage with giving the little bit of the history of ransomware and defenses and how you've got to still do the right job of protection and detection. And now I'm going to turn it over to Chad to talk about the cyber resiliencies.
Thanks, Kurt. Appreciate that. So, as Kurt mentioned earlier, we kind of have this trifecta, right? And so, what we're going to talk about here is that third bubble in the Venn diagram, right? And so, what does this mean? From a resilience and a recovery perspective, and so digging in a little deeper into the resilience and recovery piece, Kurt had stated earlier that look, when you talk about disaster recovery, that's more of an issue relative, let's say, to a physical hardware outage or a physical data center outage, right? You're making the assumption there that the data is good and what you're replicating is fantastic, right? Here, we're not making that assumption, right? We're actually making the assumption that the data has been compromised or manipulated in some way, right? And so you'll see that we introduced this terminology or this notion of what we call an enclave, okay? So what's an enclave by our terminology? Well, it's kind of a zero trust oriented concept, and we define it really as, being driven by three principles. One is enhanced identity and access management. The other one is network-based zero trust. And then finally, the notion of immutable vaulting and replication. So when we look at this diagram here, so on the top left, you might have, let's say, a customer data center, right? And then in OCI, you might have what we call a production enclave, right? And we'll get into the specifics of, what that actually might look like in terms of architecture. But this is just where you're running your application today, right? You're doing the things that you should be doing in terms of defense and depth. You might even introduce some concepts such as canary data sets, which, means that and it's kind of a deception and evasion technique where you're looking to see if someone's modifying valid data, right? And then we also introduced this notion of an air gap, right? And so traditionally, the terminology for air gap was something that was a literal gap, right? There was physically no connectivity. Well, the way we establish those gaps today, let's say in a cloud scenario or in the interconnected world that we live in, is through enclaves, right? That means that they have to be uh, adherent to the principle of least privilege. They need to really only have access when needed from a network standpoint. And then we have to introduce the concept of immutability. So here we show what we call an OCI vault enclave. And this is an area where this is, by the way, different than operational backup and recovery, right? So operational backup and recovery is, what you might use as the name implies, just for standard backup and recovery operations, but not when you're under threat of a data integrity attack. Because traditionally, operational backup and recovery doesn't support, let's say, immutability, right? And some of these other principles as well. So you should have an area where you're doing periodic backups per your RTO and RPO objectives. And might I also add here that when we talk with customers about RTO and RPO, I would argue that there's two flavors of RTO and RPO. One is regarding availability, right? In security, we talk about CIA, not the agency, but the notion of confidentiality, integrity, and availability. Well, disaster recovery addresses the A, right, the availability, but what about integrity, right? Well, that's kind of what we're looking at here, right? And so you do this in parallel or in conjunction with your operational backup and recovery. And so you have another enclave, which is what we would refer to as a clean room enclave, right? So, you know, it's one thing to back it up. It's another thing to back it up periodically and make sure that it's immutable, because if it's immutable, an attacker can't change it, even if they have administrative privileges to the tenancy. And so these are capabilities that we have in OCI, which I'll get into more in a bit. But then you have to sift through that data and identify where your last known good spot is across your unstructured data and your structured data, right? And that's kind of the purpose of a clean room. And then we need to have an area to restore to. So you might ask, well, why don't we just restore to production? Well, production at this point has become a crime scene, right? Because if you've been attacked, you've got someone in your environment, and for forensics reasons, and maybe cyber insurance reasons, that environment may need to be frozen in some context, right? And well, then it's of no use. You can't utilize it. You're doing forensics. You're trying to satisfy requirements around cyber insurance. And then, of course, there's, the point of, well, I need to restore to a clean environment so I have some level of assurance that I'm not going to be plagued by that same issue again. And then, of course, you could go back to prod or just continue going on in your safe restore. So this brings us to another eye chart. And this one's a little bit more involved. But think of this more logically and conceptually than physical, even though there are some, physical outlines here of constructs in OCI, like let's say compartments, regions, and VCNs. The way you go about implementing these sort of things can vary, right? But you remember that I had mentioned the concept of an enclave, right? Well, if you look at this diagram, you can see that we have a backup compartment, right? You have vaults, right? You have clean rooms, right? So you can think of these as those enclaves, right? And the IAM portion represents the user and group segregation, the fact that you have separate compartments that are permissioned with separate policies, separate VCNs from a network segmentation perspective, right? So let's look at it, because when we break this problem apart, we break it into two problem domains, the unstructured data problem domain and the structured data problem domain. So unstructured data here, we're talking about really anything that's not in a database, right? So what's a day in the life of let's say a boot volume, right? Or a block volume, some unstructured data. Well, it resides here in your application compartment, right? And you can back it up through operational backup and recovery, right? And that's fine, but that does not provide you with any immutability, right? And so, as I was mentioning earlier, you need a mechanism to vault this, right? So you have operational backup, that's fine, you should have it, but you should also have a vaulting mechanism, right? And we use this terminology worm OS. There used to be, optical drives, right? And that was something you'd write to once and read many. Well, in the modern day and age of the cloud, you have, object storage, and we can set it to be immutable, and it facilitates the same function, right? And so you would take that information and, we have immutable copies. So let's say if someone attacked the environment, even as admin, uh, they're not going to be able to delete the backups or encrypt the backups, right? But as I mentioned before, you still got to inspect that data, right? And that's the purpose of a clean room, is to do some level of integrity checking, scanning, and probably user acceptance testing. And then finally is find a safe environment, ideally something that you've pre-provisioned in the form of a shell. And now I'm showing everything here in the context of a single tenancy. I'll show you later that you can also do this across tenancies, right? And so there's an orchestration layer associated with this, right? Because if there isn't, then you're doing this by hand on a schedule, and nobody's going to be doing that, right? And there are means and technologies to help facilitate that, such as schedulers, the full stack DR service, even Terraform, a whole host of technology. Well, what about structured data? What about the database? Well, if you look in the bottom left here, you can see that we have a database compartment per the OCI CIS landing zone. And here we show the autonomous database. Let's just say that it's autonomous database dedicated, Oracle Exadata, or the database cloud service. Well, we have a managed service called the Autonomous Recovery Service in OCI. And this down here is in and of itself air-gapped in that it's an Oracle managed tenancy. And Oracle manages backup and recovery services for the database for you, and allows you to enable immutability of the backups, which means that not only is it air-gapped in terms of being, off tenancy, right? Because it's not in your customer managed tenancy, but you can configure it to be immutable, so that even if someone gained access as admin to your tenancy, they couldn't do anything, in terms of changing the backup. And then, of course, the name of the service is the Zero Data Loss Recovery Service, and that implies, of course, that we have single transaction level fidelity, right? And that's important. When you ask customers, how much data can you stand to lose? Most of the time they'll say, well, we don't want to lose any data, right? But then they get realistic and say, oh, it's an hour or two. We don't have to do that. We can keep it down to exact zero data loss, and Oracle will manage that for you. So great, Oracle manages it for you. You still want to interrogate that data at some point, all right? And if you're in a recovery scenario, or if you're testing, doing a drill, then you want to see what you've got, and you want to know where last known good is in terms of your transactions, right? And so you have the ability to pull from the recovery service and inspect that information. And then lastly, we can use the recovery service to, once we've figured out what that last known good is, go to that timestamp and then restore it, either using something like the full stack DR service, or scripts that you write into your safe production restore environment. And of course, orchestration can play a part in that. And then, of course, kind of the last scenario here is, well, what about a hybrid cloud? Right. So if you look at the bottom left here, so this, could be an on-premise data center, right? Customers have Oracle Exadata database running. You can use kind of the on-prem version of the recovery service, which was the precursor of the autonomous recovery service, called the Zero Data Loss Recovery Appliance, right? So it's an appliance you can purchase that can facilitate, backups locally. On-prem customers can, apply these concepts of air gaps, right? But you can also vault these things up into the cloud in a hybrid scenario, right? So in this scenario, we can vault, let's say, see number 2 here, you can vault up into block storage. We can make that immutable, right? And then, so what does all this get you across these scenarios, whether you're talking about unstructured, structured, or just kind of the hybrid cloud scenarios? Well, uh, it helps you maximize your RPOs and really minimize your RTOs, right? Because you've got to hydrate these things quickly. And the other point is you need to know what last known good is, right? And scrambling in the event of an attack is not a good place to try to figure that out. It's best to try to figure that out beforehand. So provisioning at cloud costs and cloud speed, right? And then, hydration either into pilot light or active type environments. And so, this complements DR, right? It doesn't replace DR. So you'll still have DR in whatever context you utilize DR today, whether that's, using data guard across region, what have you. This is more about the data integrity component as opposed to the availability component. So, okay, we kind of looked through a larger, higher level architecture, right? But where do we start, right? We always talk about in cloud about things being framed in terms of journeys. So, where do you start your cyber resilience journey? Well, if we look at this is kind of a microcosm of what you might see in your landing zone today, right? Minus this notion of a vault compartment. But you're going to have a network compartment. You'll probably have a hub and spoke in some context, right? You may have an applications VCN. You may have a separate compartment for database, or maybe you don't, right? Maybe it's all in one compartment. Either way, you've got resources that you need to protect, right? And so what we do is we essentially leverage through the CRA constructs at the application tier, and I'll show you a demo of this, an orchestration compute and a vault. And so this is an isolated VCN. It has no connectivity. Everything happens in terms of backup through the control plane. And then, that's how we're handling and managing, let's say, boot and block volume, and file system storage backups, which I'll cover in the demo. And then, for the database, you can see down here that we have the zero data loss recovery service, right? And so that is a managed service and an endpoint, within OCI that allows us to do that. So fine, okay, enough talking. Let's go ahead and go through an example and a demonstration. So here we're looking at the apps compartment, right? We've zoomed in even further, and you can see that you have an applications VCN, right? Let's say you have a subnet, some compute instances with block storage, and let's say that they have, boot volumes, and then you say you've got file system storages, OCI FSS with mount points, right? And you can see on the left that you have the DRG. You also see us kind of zooming in on the vault compartment here. And this is where we introduce the notion of an orchestration compute instance, right? And then an immutable bucket. And, that's the important component here. We have to get these app tier backups into this immutable bucket. So we have Terraform that can facilitate this today. And so what I'm going to do here is just pop open a zip file. And, this is the automation that we were talking about. And it's specific to the CRA Foundations Vault architecture. Okay, so I'll go ahead and we'll fill in some of the basic components here. It's pretty simple. We're saying, hey, what tenancy, what's the parent compartment for this vault that we're going to create? You can see that I put it in a compartment named Chad. I gave it a compartment name for the subcompartment. And the VCN here doesn't really matter because it's not going to be connected because it's air gapped. And we really only need the IPs for the orchestration server. And then we're going to place the bucket here. And notice that it's an immutable bucket. And the fact that it's immutable is evidenced by the fact that you can see this retention rule and retention rule locks, right? And once that lock becomes active, that means even an administrator cannot modify that. So we also use security zones to lock down the environment, and then we will provision a clean room in a separate IP space. And then we also say, hey, by the way, what is it that you're wanting to protect at the app tier? Well, in this case, it's going to be the app compartment, right? And so I'll choose the compartment. In this case, I'll identify the availability domain. And so, we're doing the app tier, right? So this is focused on the app tier. We'll run the Terraform, and through the magic of edited video, this will run, right? And so it's run and the backups have already taken place. And you can see we have something called cyber resilience protection groups that run at certain intervals where we'll have the blocks that are backed up in immutable storage now, right? We have sample data. You'll notice that there's also metadata there. The metadata is important because it's the tie that binds these boot and block and file system storage instances back to how they were constructed to begin with, because you will have to put Humpty Dumpty back together again. Okay, so what about the database tier? So let's zoom in on, let's say, a database compartment, autonomous dedicated Exadata, right? Let's say we've got a VCN. We can use the zero data loss recovery service. So the first thing we're going to do is run some Terraform that's going to automate some prerequisites. There are prerequisites you need to instantiate before you can utilize the service. Some of them have to do with inter-service policies and permissions, and then registration of what we refer to as a recovery subnet, right? And this is where a private endpoint for the zero data loss recovery service will be provisioned. Okay, so we'll go ahead and choose create here, and we will fast forward. Boom, it's done. We've applied the job. And then let's look at some of the artifacts that were created here as part of that effort. You can see that a recovery service subnet has been provisioned. And really what we did is we registered an existing subnet here, right? And we also created a policy, right? And we created a custom policy. And notice you can enable a retention lock. And that's the magic. By enabling that lock, this becomes immutable and protected from modification via ransomware. And then you have two options. Well, we've chosen the autonomous recovery service. We're going to choose the recovery service backup policy because that allows us to create the retention lock. And then we set up a schedule. And then the frequency of the data protection here is real time. So single transaction fidelity for backup of the database. So let's save that. And then, wow, that was a quick backup, right? Well, we sped it up, right? And so the backup has succeeded. And if we take a look here, we can look at some of the specifics here. Data loss exposure, you can see is 0 seconds. So there you go, kind of a fast demo of both the app tier and the database tier as it relates to the CRA architecture. So let's go ahead and continue on. If I can get past the demo slide here. There we go. And I want to show you kind of an extension. A question that we often get from customers is, that's great, but we would like to do this cross-tenancy. Is there a way to do that? And you can. And you might ask, well, why would I want to do any of this cross-tenancy? Well, in a ransomware event, you don't know what all has been compromised, right? Your identity plane is suspect. at this point, right? You can try to repave your identity plane, but a lot of customers would feel a lot more comfortable if they had maybe an entirely separate tenancy with, let's say, break glass, right? And let me go back here and I'll kind of zoom in on some of this, right? So you can see this, you don't have any federation. So if your, IDP gets compromised, who cares, right? And then we kind of have this framework that we had, with the landing zone. But here for the database, we're using data guard replication. If it's the autonomous database, you support it through the console and you can do it natively. But you can configure it if it's not the autonomous database, you can configure it manually across tenancy, right? We just have to have the right connectivity. We need to have DRG connectivity between the tenancies, right? Some level of peering. And usually it would be back to this hub spoke. And then remember, we took these app tier, and of course, that was the database tier we're talking about. At the app tier, we took these backups, we put it in the immutable bucket. Well, we can use something like rclone and schedule it, and then just push this over into the immutable bucket. And then you have a safe room compartment here. You can start testing and automating the hydration of that information. And so if you have a full-blown DR event, you can even take it to the next level. Now, there's pros and cons to everything, right? There's more administrative overhead associated with this, but arguably, it would be potentially a more secure option and solution. So some things to remember here as we the old, tell them what you told them. Well, we talked about cybersecurity, right? That's kind of the landing zone where we're doing the protect and detect sort of activities like patch management, AV, nailing the basics, like Kurt mentioned earlier in the presentation. You still want and need disaster recovery, although it's not really a data integrity issue, it's an availability issue, right? It's still an issue, right? And it still needs to be accounted for. But now what we're saying is, hey, look, make sure that you round out this notion of a well-architected OCI environment with cyber resilience, right? And that's through enhanced identity and access management, through microsegmentation, XDR, EDR, threat hunting, addressing unstructured data and structured data through things like the Zero Data Loss Recovery Service, right? And so a lot of our customers are kind of here where this happy little guy, this little stick figure is, but we want to get our customers here, right, at the confluence of cybersecurity, cyber resilience, and disaster recovery. So fantastic. So what are the next steps here, right? Well, this can be a little bit daunting. And I would say, hey, reach out to your account team, right? Your account team can get you in touch with us, right? And we're the security organization, the Office of the Field CISO, the security specialists. We work as one happy unit to accelerate our customers along this security journey, right? And that's what it's about. It's about acceleration, right? And we help you start small. We help you with automation. We help you with best practices. And then, we have assets as well, right? Like Kurt and I have published several blogs on the topic. You'll have those links and data that's provided post-webinar. You also have the Oracle Architecture Center, and we have a cyber resilience reference architecture, which is along the lines of what I showed you in the overall cyber resilience slide. And so now I'll turn it over to Bhakti and Renu to kind of talk about, where you go from here.
Thanks a lot, Chad. Here are some resources that you can refer for Oracle Cloud training, certifications, live labs, and also Oracle Cloud documentation. So please check those links out once you get the presentation. Now here, what you see on the screen is some additional Day 1 and Beyond series where we keep adding new webinars on trending topics. So please check those links as well. I would also recommend you to please bookmark the Day 1 and Beyond page. With that, thanks a lot, Chad and Kurt, once again for an awesome session today. Thank you. With that, thanks again for joining us. See you all next time. Have a great day, everyone.